We all think of solar panels and wind turbines as our best shot at fighting climate change. But what if building them actually creates its own massive carbon footprint? Today, we're going to dig into the real data and uncover the true cost of clean energy.
Right now, we are smack in the middle of a colossal global shift, maybe the biggest one in 100 years. It's called the energy transition, and it's basically a complete rewiring of how we power our lives, moving away from the fossil fuels that, let's be honest, built the modern world. So what exactly is this energy transition? Well, think of it like a system-wide overhaul. The whole point is to swap out our entire fossil fuel infrastructure, coal, oil, and natural gas, and replace it with renewable alternatives. And the number one reason for doing all this? You guessed it, to get a handle on climate change. But this whole transition brings up a really tough question, one you've probably heard before. Does making all this new clean tech, all those solar panels and wind turbines, create so much pollution that it just cancels out all the good stuff? Are we just trading one kind of environmental problem for another? This right here is the heart of the skeptic's argument. It's all about the hidden emissions, the carbon footprint from mining all the materials, manufacturing the parts, and actually building these huge renewable energy projects. And you know what? It's a fair question. It deserves a serious, data-driven answer.
Edgar Hertwig from Yale University, he sums up this common worry perfectly. People want to know, is the energy we have to pour into building a low-carbon future just too high? So how do we actually find out?
To get to the real truth, we can't just look at what's coming out of a smokestack or a tailpipe. Nope. We have to look at the whole picture, from the very beginning of a power source's life to the absolute end. And scientists have a tool for this exact job. It's called a life cycle assessment, or an LCA for short. It's basically a way of doing full carbon accounting for an energy source, from cradle to grave. So what does a life cycle approach actually measure? Well, it tracks emissions across every single phase of a project. We're talking about building the plant, getting the fuel, its day-to-day operation, and even tearing it down at the end of its life. We're talking about the whole shebang, the emissions from construction, from supplying any fuel, from actually making the power, and finally from taking it all apart. Every single gram of carbon gets counted. So with this tool, we can finally put every energy source on a level playing field and see how they really stack up. And the results? Well, they're pretty incredible.
Okay, first, a really important high-level point. For fossil fuels like coal and gas, almost all of their carbon footprint comes from when they're running, when they're actually burning fuel. For renewables like wind and solar, it's the exact opposite. Most of their emissions are front-loaded, happening during manufacturing and construction.
And here's where the massive scale of the difference really hits you. When you add everything up, coal pumps out around 888 tons of CO2 for every unit of electricity. Natural gas is better, at 499 tons. But then you look at wind. It's just 26. This isn't a small difference. It's a canyon. And this pattern holds true across the board. This data, which comes from tons of different studies, shows that all the low-carbon sources are just in a completely different league. You've got wind down at 26, nuclear at 29, and even solar, which takes a bit more energy to make, is only at 85. They're all just a tiny fraction of the emissions from gas and coal.
And here's the real kicker. Even if you bolt on expensive carbon capture technology to a fossil fuel plant, its total life cycle emissions are still about 10 times higher than wind or solar. 10 times! That one fact really puts a dent in the whole idea of clean fossil fuels.
So the verdict from these life cycle assessments is really, really clear. Yes, renewables do have a carbon footprint from being made, but that cost is paid back many, many times over during their lifetime. The climate benefits aren't just real, they're absolutely overwhelming.
Okay, so the science is solid. But what's actually pushing this huge global shift forward? It turns out it's not just about the climate. There are really 4 key things driving this transition. Of course, there's climate change. That's a big one. But there's also energy security, nations wanting to control their own power. There's economic development and the promise of new green jobs. And finally, maybe the most powerful driver of all is just simple economics.
Just look at these numbers. Between 2010 and 2019, the cost of solar energy absolutely plummeted by 85%. Wind energy dropped by more than half. And batteries? They fell by 85% too. This isn't just an environmental movement anymore. It's a full-blown economic tidal wave. In many parts of the world, building new solar or wind is now the cheapest power you can get.
And this brings us right back to where we started.
As the Yale study concludes, because the life cycle emissions of renewables are so incredibly low, a future powered by them is genuinely a low-carbon one. The data confirms that this path isn't just a nice idea, it's completely feasible.
So the science is clear, the economics are lining up, the technology is here, and it works. The real question isn't if a clean energy future is possible, but whether we can actually build it fast enough. Can our global transition keep pace with the problem? That's the real challenge for all of us. Thanks for tuning in.